Parameter studies. The antenna structure is a distorted symmetrical dipole. So, the length of metal loops and the input impedance could be estimated based on dipole theory. If resonant frequency is determined, the electric length of a metal column, quasi-half loop and folded terminal should match the resonant frequency. Where loop is the length of one quasi-half loop. It is needed to consider the quasi-half loop's mirror image function on the ground plane of microstrip during designing. Metal column should be long enough because current mirror image is reversal and then it will cancel out a part of magnetic field. But if metal column is too long, magnetic field will be weak for the weak current on small quasi-half loop because of the unchangeable resonant frequency. Phase and magnitude of the current on both quasi-half loops are symmetrical so that magnetic field can be strengthened simultaneously by two quasi-half loops. Most of energy consumption of the antenna attributes to ohmic consumption on metal and loads, which could sharply reduce gain and broaden the bandwidth. After extensive simulations, it is found that loads, Rs 1 and Rs 2, the length of hand loop affect antenna performance significantly, whereas the other parameters show slight effects. The antenna with the parameters, route equals 34 mm, RIN equals 25 mm, phi equals 160 degree, L equals 8 mm, W equals 2 mm, Rs 1 equals 30 ohm, Rs 2 equals 50 ohm, H equals 15 mm and T equals 2 mm was selected as a reference. All the simulation results of magnetic field distribution in this lecture are Z orientation. In this section, magnetic field is observed on the reference plane equals 1 cm above the top of the antenna with radius of 50 mm. Set the upper surface of top layer as Z equals 0, so that the distance between reference plane and antenna could be figured by the value of Z. Z-axis passes through the center of both top and bottom PCB boards. Figure 10a and b shows the magnetic field distribution of antennas at different values of Rs 1 and Rs 2, respectively. It is observed that magnetic field distribution is sharply reduced with the increasing of Rs 1 and Rs 2 at the operating frequency. As shown in tables 1 and 2, it could be found that the bandwidth and magnitude of S11 are also narrowly related with Rs 1 and Rs 2. The relationship between loads and magnetic field at 868 MHz, a Rs 1 versus magnetic field and B Rs 2 versus magnetic field. Relationship between the Rs 1, resonant frequency and bandwidth. Relationship between the Rs 2, resonant frequency and bandwidth. Both magnetic field and return loss are more sensitive to Rs 1 than Rs 2, because the current of Rs 1 is much stronger than that of Rs 2. From tables 1 and 2, it is found that Rs 1 or Rs 2 affects resonant frequency slightly and bandwidth and S11 at resonant frequency significantly. Figure 11a and b exhibits the magnetic field distribution of the antennas with varying heights of 868 and 915 MHz. The antennas are configured with identical length of RIN and L. It is observed that all the antennas have similar magnetic field except H equals 5 cm, when changes from 5 to 35 mm. It could be inferred that the magnetic field is sharply cancelled out by current mirror image of the ground if his too narrow. Current mirror image is too weak to influence the magnetic field when the length of is longer than 15 mm. The relationship between the hand magnetic field at different frequencies, A, 868 and B 915 MHz. Radius of quasi-half loop is also an important influencing factor of magnetic field. In the experiments, other parameters are unchanged except root because radius of root is narrowly related with that of RIN. Figure 12 shows how magnetic field changes with different RIN. It is clear that magnetic field should be weaker if the RIN is too small or large at 868 MHz. The total length of loop in is far less than lambda 4, 8.64 cm, and average current strength on the loop is naturally weak. But the reason for weak magnetic field at large RIN 40 mm, is the decentralization of magnetic field energy. Magnetic field distribution of different RIN 868 MHz.